Number 5, argument of the product. I think it should be an. Okay, an argument of the product Z1, Z2. So suppose that Z1 has this polar representation and Z2 has this polar representation. So absolute Z1 is R1, absolute value Z2 is R2, and we see that little arg of Z1 is theta 1, and little arg of Z2 is theta 2. Of course, big arg of Z belongs to the collection of all the collection of all arg Z, right? So actually I can write arg Z as a set. Arg of Z belongs to this set. Big arg of Z plus 2k pi, k in Z. I can write all arguments of Z as a set, taking the representative and vary by 2k pi. Any one of these will be an argument of Z. Okay, so anyway, what is the, then Z1 times Z2 is, also let's multiply that. So Z1 can be written as R1 cosine theta 1 real part, R1 sine theta 1 imaginary part. That's Z1, and we multiply that by Z2, R2 cosine theta 2, R2 sine theta 2. So remember the multiplication, 이렇게 해서 빼고, right? That's the real part. 그러면 그렇게 하면 R1, R2가 나올 거고, right? We'll get cosine theta 1, cosine theta 2 minus sine, let me put that in one parenthesis, sine theta 1, sine theta 2, comma. So that's the real part. And for the imaginary part, we do 어떻게 되는 거죠? 아니. No. 이렇게 그리고 이렇게 해서 합하는 거죠. Right. So there again we will get R1, R2, R1, R2, and then we get cosine theta 1, sine theta 2, plus sine theta 1, cosine theta 2. So that's the product. Well, R1, R2 are both real, so it can be pulled out. So that is equal to, it can be written as R1, R2, parenthesis, and what is this? That's cosine theta 1 plus theta 2, comma, and what are these? Sine, cosine, cosine, sine. So it is sine of theta 1 plus theta 2. So then Z1, Z2, so absolute value Z1, Z2 is R1, R2. That is absolute value Z1, absolute value Z2. As we have seen earlier in your practice problem, right? And we see that arg of Z1, Z2, an argument of the product Z1, Z2 is theta 1 plus theta 2. That is an argument of Z1 plus an argument of Z2. important. Okay. So for the argument of the product, you just add two individual arguments. There's more. Hence arg Z1, Z2 is arg Z1, an argument of Z1 plus an argument of Z2. So for example, what is arg? So if I call that Z is a product, right? So it's Z times Z. So it is asking what is arg of Z squared. That's what it is asking. Then it will be by what we did above, it will be 2 times arg of Z. So let's find what arg of Z is. So if I draw as real, imaginary, this is real part minus 1/2, and that's the imaginary part minus square root of 3 over 2. Here, that's Z. Okay, so if I have this right triangle, then that data is tangent inverse of this much is square root of 3 over 2 over that much is 1 over 2, right? So again we get pi over 3. That angle is pi over 3. So one argument is this. That is 4 pi over 3. So arg of Z is 4 pi over 3. Or you can say 4 pi over 3 plus any 2k pi for some k in Z. You can say any of these as your answer. You can say any of these as your answer. Any of these, right, as your answer. So anyway, this is twice 4 pi over 3. So that is 8 pi over 3. So what is an argument? What's little arg of Z squared? Is 8 pi over 3. Or you can say 8 pi over 3 minus 4 pi. For example, there could be many answers, right? Many possible answers. And what is big arg of Z squared? It's the same Z. So among the arg of Z squared, we have to pick one bigger than minus pi, less than or equal to pi. Yep. So see what we have. Z is here. So it is clear that Z has length 1. And it is 4 pi over 3. Is 1 arg of Z. Right? But when we do Z squared, it is clear that absolute value of Z squared is 1, and 1 arg of Z, an arg of Z was 8 pi over 3. Oops! It's not arg of Z, it's arg of Z squared there. Okay? Arg of Z squared is 8 pi over 3, which is 2 pi plus 2 pi over 3. So if we draw that, z squared here. Z squared has length 1, same length as z, and it is 2 pi plus 2 pi over 3. So it ends at 2 pi over 3. So this is, since it is between minus pi and pi, this is big arg of z squared, principal argument. So going back to here, where are we? And big arg of z equals to 2 pi over 3. Unique answer. Okay. So using this with induction, one can show that, so from the previous z squared is absolute z squared cosine twice arg of z, comma, sine, let me put the parenthesis here, sine of twice arg of z. That was what we derived in previous numbers. So we can show by induction that, one can show by induction, we can show this. If theta is an arg of z, let's say theta is an argument of z, then z to the n is absolute value z to the n times cosine n theta, comma, sine n theta. In other words, this is equal to absolute z to the n cosine n theta is the real part plus I absolute z to the n sine n theta is z to the n. What is n? We are showing that by induction, right? So n is natural numbers. N is 1, 2, 3, etc. When absolute value of z is 1, we get famous 드무아브루. 그러니까 한국말로 읽으면 아브라함 드무아브루. 영어로 하면 DeMoivre. He's a French mathematician who actively worked in Britain. Okay. So anyway, this is his theorem. DeMoivre theorem. DeMoivre's theorem. If you have to refer to it, you can say DM. Okay. DeMoivre's theorem is the following. When absolute value of z is 1, so z to the n is cosine theta plus I sine theta, because that is because absolute value of z is 1, right? So we have that thing to the power n equals to, by what we showed in number 6, by number 6, this is equals to cosine n theta plus I sine n theta. for n equal to 1, 2, 3, etc. This is DeMoivre's theorem, and we'll use this as a tool in proving something later. Okay, DeMoivre's theorem. All right, memorize. Now let's look at polar representation of 1 over z, multiplicative inverse of z. So what was 1 over z? Remember from before, if z is a comma b, then 1 over z we calculated. So that was a squared plus b squared a comma minus b over a squared plus b squared. Which is, well, since this and that is real, we can take that out. Then what I get is actually a minus ib. So this is z bar over absolute value z squared. So that's 1 over z. Right? So how do we find the polar representation of it? Well, we can do this. So this part, 1 over absolute value z squared, is real. So it comes out as it is. Let's look at the polar representation of z bar. So again, if z is here, then there's z bar, right? So that's real axis, and that's imaginary axis. So their absolute value is the same. And if this is an argument of z, then that is an argument of z bar, right? So z bar has polar representation as absolute value z bar times cosine of minus of arg of z, comma, absolute value z bar sine of minus arg of z. If arg of z is theta, then arg of z bar is minus theta. So that's minus arg of z. And since this is equal to absolute value of z, we can cancel this and one of these. Alright, so we're left as follows. So this is equal to 1 over absolute value z cosine of, what is cosine of minus theta? That's cosine of theta. And sine of minus theta is minus sine theta. Right? So it is cosine theta, comma, minus sine theta. So that is polar representation of 1 over z. Polar representation of 1 over z is this. So absolute value of 1 over z is 1 over absolute value z, and an argument of 1 over z is, it came from here, right? It is minus arg z. So that's what we get. 1 over z. You will have to memorize everything. Right? We get this and that from minus of the angle. So that's minus of arg of z. Okay. So then what is polar representation of z1 times z2? So z1, not times, z1 over z2. That means, by notation, this means it is z1 times the multiplicative inverse of z2. That's what it means. So from previous discussion, z1, if we have z1, let me write this, CW. If we have two complex numbers, CW, then absolute value of ZW is absolute value Z, absolute value W, and argument of product ZW is an argument of Z plus an argument of W. Remember, right? So we get C1 over absolute value Z2 as the absolute value of Z1 and Z2. This is absolute value of Z1 over Z2 times we get cosine, and the argument of 1 over Z2 was minus arg of Z2. So it is cosine theta 1 minus theta 2, comma, sine theta 1 minus theta 2. That's polar representation of C1 over C2. Because 1 over Z2 has polar representation as 1 over absolute value Z2 cosine minus arg of Z2. So, yeah, cosine minus arg of Z2, comma, sine minus arg of Z2. Right? So that's why this is true. So it is this where theta 1, theta I is an arg of Ci. Okay.